Right, so here's some examples of trying to work out circles and angles within circles. Okay, so what we've got here, you can see that there's a few triangles within this diagram. So you just solve one triangle at a time. So ultimately, we are looking for calculate the size of angle QRS. Okay, so QRS. So we're actually looking for this angle, right? So that's what we're looking for here. Now, what we've got, if we have a look at this wee triangle, so if you have a look at POS triangle, this is an isosceles because what we've got is we've got two of the sides are actually radius of the triangle. So what we know with that is two of the angles are the same. So if I just, so this angle, okay, so that angle there, which is OSP, so angle OSP, that also equals 28 degrees. Now that's handy knowing that, because if you then have a wee look at this triangle, which is PQS, now one of its sides is an actual diameter of the circle, so we actually know that this must be a right angle. Now we've already accounted for, in this right angle, 28 degrees, so the difference between 90 and 28 is going to be this angle, okay, so that's OSQ. So we can say OSQ is actually the 90 degrees, because any triangle in which a diameter is one of its sides is going to be 90 minus the 28. So that must mean that is 62. Okay, so that side is 62 degrees and that side is 28. Now, that's us working towards finding out this angle. Now, from this, we can actually work out this angle, okay? Because 28 degrees, 28 degrees. Remember, 180 degrees in a triangle. So what we can actually work out here is we can think about this side as being 180 degrees minus 28 degrees minus 28 degrees, okay? So if we think of the angle POS, that's going to be 180 minus 2 watts of 28. So I'll just get the calculator out here. So that is 180 minus 28 minus 28. And that's 124 degrees. Now, this, just like any line, okay, if you take a line, that's 180 degrees, okay? Now, the line PQ is 180 degrees, and we know this is 124. So we can actually now work out this angle. Let's choose another colour, right? So we can then work out this angle, and this angle is the difference between 180 and 124. So if we then say the angle of QOS equals 180 minus 124, okay, and that will equal 56 degrees. So we're nearly there, right? So that is 56 degrees. So what we can now do, okay, so we can now work out this, because we know that this triangle has got 56 degrees, 62 degrees, and obviously 180 degrees in the triangle. So the actual OQS equals 180 minus 56 minus 62. There's probably even a quicker way of doing it, and that is 62 degrees. Now, when I say there's a quicker way of doing that, what I should have looked at is the fact that this is an isosceles triangle, because just like this one, because two sides are the radius, so that side has to equal that side. Okay, so we're nearly there. Now again, the same rule applies. This angle plus this angle should equal 180. Okay, so 180, so this is angle SQR equals 180 minus 62. Okay, and that gives you 118 degrees. So this is 118 degrees. This is meeting this line at a tangent, so that is going to also be a right angle. So if I counted for 62 degrees of it, so therefore that side here must be 90 minus 62, and that is 28 degrees. So we have this triangle in which we've now got two sets of values. So we can say angle QRS equals 180 minus 28 minus 118 equals, get the wee calculator up, knowing my luck I've made a wee mistake along the way, minus 28 minus 118, and that is 34 degrees. That should be your answer. Okay, so I should have looked myself and actually seen that that's an isosceles, and that would actually cut down some of the working out here. Okay, but that's essentially, you just break the problems down into the separate triangles. You know the rules in terms of if there's tangents, or if there's a diameter for a side, or two radius for side, or radii for sides of triangles, and you'll get the solution. Right, here's another wee example. Try and do it quicker than the last one. Now, first triangle we've got is a diameter is one of the sides, so we now know that that's going to be right angle. Okay, also know with a line that it's 180 degrees. So, bearing that in mind, we can now calculate this angle. So we can calculate angle CEP, because that is going to equal 180 minus 90. So surprise, surprise, that is 90 degrees as well. Okay. Now what we've got is we've now got a triangle in which we actually know two sides. I'll just say that's 90. Right, so we now know two sides. As long as you know two angles within a triangle, you can always work out the third one. So that must give us angle EPC equals 180 minus 90 minus 48. Let's put that in the calculator there. So 180 minus 90 minus 48. That gives us an angle of 42. So that is 42 degrees. Can get a wee bit cluttered. We've also got another wee rule that we can use, and that rule is the fact that we've got a line that's meeting a tangent, and that's going to be right angles. Now we can account for 42 degrees out of the 90, so that must mean that's 48 degrees. Okay, now we're looking for EPR. Okay, so we're looking for, choose a different colour that I've not used. We're looking for this angle. Okay, now that's going to be right angles as well. So what we've actually now got is this angle is going to be that 48 degrees plus the 90 degrees. So angle EPR is going to equal the 48 degrees plus the 90 degrees, and that equals 138 degrees. Okay, so that's EPR, right? So EPR, that's 138.